All right, hey guys, this video is going to go over transforming functions, and we are going to see what actually happens when we transform a function using the rules that we've been working with. So while you're watching this video, I suggest you have your notebook out so you can take some notes, and then you're also going to want to have Desmos.com pulled open or the Desmo app on your iPad so that we can go back and forth between the video and that. All right, so here's what we're going to start with. So let's say that we have this function, f of x equals x plus 1. Now, you guys should know that this is going to make a line. The y-intercept is 1, obviously, and so is the slope 1. So first of all, we're going to go to Desmos.com or the Desmos app, and we are going to type that function in, and I'm going to show you how to do that. All right, so when you're in the graphing calculator on Desmos.com, you are going to type in f of x. So you just come right here. Just start typing. F of x just goes like that. Your keyboard probably shows up too, so I'll get mine up. And then you type equals x plus 1. Okay, you're going to notice right away that it graphs it for you. Now to get rid of your keyboard, you can come push this little button here, hide keyboard. But you should see there is a line. It has a y-intercept of 1, and it also has a slope of 1. Now, you guys might notice my graph looks a little funny. It's counting by a half. I can always change that with this toolbar over here. So if you guys click on that, I just want to show you a few things. It's going from negative 10 to 10. The y-axis, it only is going from negative 6 to 6. I usually just change them both from negative 10 to 10. Okay, and then it usually changes it to count by ones. Okay, so again, there's my graph. It's got my y-intercept of 1, and it's up 1 over 1. Okay, now you guys see this dot over here, it's red. That shows me that this is the red line. Okay, I'm going to switch back to my other screen. So we have that line graphed in Desmos. Now, here's the transformation that we're going to do. Okay, so basically, I want to take this function, and I want to transform it using this rule, f of x plus 4. Okay, so we learned in the last video how you can transform this function using this rule. So basically it's saying take that function, add 4 to it. So I kind of showed that down here. I took the original function, x plus 1, that kind of lines up right here, and then I added, so here's the original function, and then I added 4 to it. All right, so I am going to go back to my graph, and I'm actually going to type that in, and we're going to see what happens. So when you go back to Desmos, you're going to click in the next box. Okay, I'm going to start by typing f of x again, and then equals, I'm going to type my original function, x plus 1, and then it said to add 4 to that, add 4 to it. Okay, I want you to take a look at what happens. Okay, so now this one is blue. You guys see this blue dot. Yours might be a different color. So that matches with my new line. So what happened to that line? Okay, so what are some things that happened? I want you to pause the video and think about what happened so far. Okay, here's what I noticed. It looks like the same steepness. These lines are parallels, so the slope didn't change. Okay, but my y-intercept, it looks like it moved up 1, 2, 3, 4. That's actually called a translation. It slid this line. Basically, I took this line, and if I grabbed it and just slid it up 4 units, 1, 2, 3, 4, it would land on top of this blue line here. So this transformation, what happened, again, the slope stayed the same, and it slid or translated up 4 units. All right, so again, I could rewrite this too if I went back to the rule. You could combine that in x plus 5. Now, when I'm looking at these, here's kind of what I noticed. This was my original. Okay, if I'm looking at this, I see, okay, looks like my slope was just 1 right here. Now my slope in my new one down at the bottom is also 1. Okay, my y-intercept was 1. Now it's 5 in my final one. So I can tell, well, it changed by 4. So this rule right here makes it, let me just highlight it. Looks like it translated up 4 units. Okay, so what do you think if I went back to the original line, but this time I did f of x minus 4? What do you think might happen to that line? I want you to pause the video and go try it. See what happens. Okay, you should have tried that. All right, here is our next one that we are going to do. Sorry. Okay, we're going to start by graphing this one. So when you go to Desmos, I'm going to go back there to Desmos here. To get rid of your graphs, you can always just click this X in the corner. So I'm going to click this X. Okay, now I'm going to type in my next one. It's f of x equals, okay, I'm going to pull up my keyboard here. I'm going to type in x, and then right here is where you get the squared button. So you can just type in a squared, and then I'm going to hit plus 1. All right, you guys should have known that this was going to be a parabola, but here's what it looks like. It has a y-intercept of 1. There's no x-intercepts on this one. Okay, so I have that graphed. Obviously, you guys can see there's a green dot now, so it matches up with my green one. All right, now here is how I'm going to transform that parabola. Okay, we're going to use this rule, f of x minus 4. You should have just explored what you think will happen, but take a guess again. What do you think is going to happen to this parabola if I transform it using the following rule? Okay, so if I transform it, again, it says take the function, okay, which I did right there. I wrote it out, and then it says subtract 4 from it. So subtract 4 from it. So let's go back to Desmos, and let's see what happens. Okay, I'm going to click on a new box. I'm going to type in f of x, oops, and then equals. I'll type in the x squared again, and then plus 1. There was my original function. You can see it's right on top of the other one. But then I'm minusing 4. All right, what happened to this? All right, so if you take a look, okay, here was my green one, here's my new one in purple. All right, now it may look like it's starting to get wider. It is not, okay? If you just pick like 2 points, like I'll pick this one and count across, it's 1, 2, 3, 4 across. Okay, and then I'll pick this one here, 1, 2, 3, 4 across. So it's still same distance across. It looks like all it did was this green one slid down, or translated down 1, 2, 3, 4 units to land down here. So it's the same parabola. All it did is it slid down, or translated down 4 units. Hopefully that's what you guessed. All right, so when you are looking at this, obviously here was your new rule, and then if I kind of simplified it together, it looks like this. Okay, I can still see the x squared part stayed the same, but the y-intercept was 1 up here. Now it's -3 down here. So again, basically it just slid down 4 units. All right, we are going to try another one. All right, so our next one is f of x equals 3x plus 1. Again, you guys should know that that is a line. So go ahead and clear your graphing calculator and type that in. So I'm going to get rid of this one. I'll just come to this one and just backspace a little. And I'm going to type in 3x plus 1. All right, obviously I see a line with a y-intercept of 1 and a slope of 3, up 3 over 1, up 3 over 1. All right, here's how we're going to transform this one. So we're going to use the following rule. Okay, it says to take f of x, or take the function and add 2 to the x value. So that means I'm going to have to come right up to here and add 2 to just that x. Okay, now watch how I show it algebraically. So again, I started with the 3. Here was the x. I had to add 2 to it, and then I wrote the plus 1 at the back. Okay, now if you want, you can simplify that. I'll distribute it out. It turns into 3x plus 6 plus 1, or my final new one is 3x plus 7. So let's go ahead and we can type that in a couple different ways. I'll just go to the final simplified one. F of x equals 3x plus 7. All right, so if you guys take a look at this one, let's see what it looks like happened. Okay, first of all, look at their slopes. It looks like the slope stayed exactly the same. Do you guys notice how it's 3 and 3? These two lines are parallel again. So the steepness stayed the same again in these lines. Okay, the y-intercept looks like it changed, right? But if you go from the green to the black, what really looks like what happened? Does it look like it went up? Does it look like it moved down? It definitely didn't move down. You could say it sort of moved up, but actually this time it actually slides left. I'll come to this point. It slides left 1, 2, it looks like 3 units. Okay, now look back at the rule that we just did. Oh, sorry, 2 units. I was counting wrong. It looks like it slid left 2 units. Okay, we're going to do another one to kind of see how that compares. So that one, for now, it looks like it moved left 6 units. Okay, let's do another one. Okay, here's our next one. F of x equals x squared plus 1. We are going to transform it using this rule. it says take the function and subtract 2 from the x value. So again, I'm going to take this x here, subtract 2, and then rewrite the rest of the rule. So here's what I did. I have my x value. I subtracted 2, but then it says squared plus 1. Now this is how I'm going to type it in on my, my calculator. So let's go ahead, go back to Desmos, and type in f of x equals x squared plus 1. Okay, this time on my new one, I'm going to do f of x equals, I had parentheses, x, I subtracted 2 from it, then I squared it, and then it still said plus 1. All right, it's kind of a little bit easier to tell on parabolas than lines. That's why I wanted to show you guys one like this. So again, my rule was all I did was subtract 2 from the x value. Look what happens from my original red parabola to my blue one. Again, it looks like they're the same width, so they didn't like shrink or stretch or anything, but it looks like it just slid over. Look at its vertex. It looks like it slid over 1, 2 to the right. Okay, so think about this one. Our last one slid 2 to the left over. This one slid 2 to the right. Look at the symbol. Here it was x minus 2, and the other one it was x plus 2. So it's kind of opposite of what you would think. In this one, if it's minus 2, it's going to slide to the right 2. In the other one, it was plus 2, it slid to the left 2. And try one more. So let's do an absolute value one. We haven't done one of those yet. So here's our original function. F of x equals the absolute value of x plus 2. We are going to transform it using this rule. We're going to take the x value, add 3 to it. So let's see what happens. So here I had my x value, I added 3 to it, and then I still had that plus 2, and it's still an absolute value symbols. So we are going to, you could rewrite that as f of x, or f of x equals the absolute value of x plus 5 as well. So let's go to Desmos and let's start. I'm going to clear this calculator. I want to show you guys how to type in absolute value so you know. So f of x equals, okay, your absolute value symbols are actually right here. You see this A key right here? So I'm going to type that in. And then it was x plus 2, I believe. I just better double check. Yep, okay. So there's my absolute value graph. Now when I transform it, hopefully you guys kind of guess what you think is going to happen. It's f of x equals, okay, this time I added 3 to it, and then I still had that 2 inside there. And then there's my absolute value symbol. So let's see what happened to it. Okay, it looks like, my green one was the original one. It looks like it slid to the left 1, 2, 3. If you look at the vertex, that's kind of an easy way to tell what happened. The width of the V stayed the same, so it didn't like stretch or shrink or anything. It just moved 1, 2, 3 spots to the left. And remember, the function rule was plus 3, so it actually moved 3 to the left. So we have learned 4 transformations so far, and you guys can keep playing with this on your graphing calculator, but so far we have learned that if you take a function and you take the function and you just add a number to it, this could be a 3, a 2, a 5, that's going to be a vertical translation up k units. So it's going to slide up whatever this number is. If I took that same function and I subtracted k from the entire thing, it's going to be a vertical translation, but this time it's going to go down whatever number that is. So it might go down 6 units. Okay, these are the last 2 we did. If you take the function and you add a number to just the x value, that's where it's going to be a horizontal translation. That means slide. It's going to go left k units. So it's kind of opposite of what you would think because it's got plus k. It's actually going to go left however many units that is. And if I take it again and I do if I subtract a number just from the x value, it's going to slide right that many units. So those are the 4 that we have learned so far. Now, what you're going to do next is I'm going to have you explore 4 other rules to see what happens. Okay, so you're going to be set up. It's going to walk you through it, but you're going to use Desmos, and you're going to see if you can figure out, well, what does happen with these rules? All right, thanks for watching, and hopefully that made sense. I'm sorry this got a little bit long.